Welcome, and thank you very much for joining this presentation titled Improving Chip Design Performance and Productivity Using Machine Learning. My name is Narender Hanchate. I'm a senior machine learning architect at Cadence Design Systems, responsible for developing EDA tools with latest machine learning technologies, and I'll be presenting this session today. Let's first start by setting up some context to this presentation. Semiconductor industry is experiencing a resonance. What I mean by that is new application and technologies are driving demand for more compute power and functionality in devices that we use today. We are experiencing a strong growth based on new technologies like 5G, autonomous driving, hyperscale compute, Internet of Things, and many more. We all want more powerful devices, higher performance, better graphics, longer battery life. This is triggering an explosion in chip sizes and the complexity. Take GPU for example. A few years ago, 1080p was considered a high resolution, but today 4K displays are becoming a standard. Some high-end devices even support 8K resolution. So a graphics design is significantly large and more complex today. And to add on that, chip designers are moving to newer and advanced process nodes. The standard cell libraries are becoming bigger and bigger, and there are many more PVT corners that need to be considered before a chip is signed off. All these things are making chip design a lot more complicated, and it's really difficult for implementation and engineering teams to keep up. Hence, the need of the hour is not just the advanced EDA tools, but also need automation of CAD flows and methodologies to enable the design teams to take on these large and complex implementation projects. Cerebrus is based on three key technologies. Cadence has invested in a multi-year R&D effort, creating a unique reinforcement machine learning engine, which enables Cerebrus automated flow optimization to deliver better engineering team productivity as well as PPA improvements. Cerebrus is a full-flow RTL to GDS2 optimization tool. This is critically important as the flow changes during Genus RTL synthesis will affect later flow changes during Innovus implementation and vice versa. So you have to consider the full flow to achieve a global PPA improvements. If only one stage of the flow is considered, then you will never find the optimal PPA solution. To run the different flow scenarios, Cerebrus utilizes scalable and distributed computing, which can be run on-premise or in cloud. It is a combination of these three technologies: reinforcement learning, full flow optimization, and distributed computing that enables Cerebrus. Now let's get into the details of how Cerebrus works. As the designs and CAD flow are becoming more complex, it is computationally feasible to evaluate every hyperparameter combination to achieve the best possible PPA. Cerebrus efficiently optimizes the design flow using a powerful reinforcement machine learning engine. It works on the principle of generating the state space on the fly by combining hyperparameters to generate a flow scenario. It then generates the actions for expected improvements through a continuous rewarding mechanism. The RL engine efficiently optimizes both the breadth of the flow scenarios and the depth of the flow phases throughout the full flow. If the full flow scenario is not generating an improved results, then RL engine will terminate the run immediately and use the workstation for a different flow scenario. In this way, Cerebrus makes efficient use of available compute resources. The reinforcement machine learning model is automatically saved to transfer full flow learnings from one design to another, helping Cerebrus converge even faster, providing a significant boost to productivity and PPA. Now that we have gone through how Cerebrus works, let's look at some of the results. This is a typical 5 nanometer high performance mobile 3.5 GHz CPU design. The designer used Cerebrus to automatically optimize the implementation flow to improve both power and performance. You can clearly see that the results are quite significant with a 420 megahertz improvement in performance and also showing the good power reduction at the same time. This was achieved by one engineer using Cerebrus for about 2 weeks. If the designer tried this flow manually, then it would have taken many engineers for many more months. Even then, it is questionable that if these PPA numbers would have been achieved through manual exploration. This is a great example of productivity benefits that Cerebrus enables. If you would like to understand more about how Cerebrus reinforcement learning flow optimization works, take a look at the product page at cadence.com/go/Cerebrus. This page contains a lot more information such as white papers and videos, and also you can always contact local Cerebrus support team. Many thanks for your time and attention today.